In Kubernetes, command and args are about the first process inside the container. If that process exits, the container exits, and pod behavior follows the restart policy. Official docs state the mapping clearly. In Kubernetes, the command field corresponds to entry point in many runtimes, and args corresponds to CMD. If you set command and args, they override the image defaults. If you set args without command, Kubernetes keeps the image's default command and passes your new arguments. Another important docs detail: the command and arguments defined for a container cannot be changed after the pod is created. Change the manifest and create a replacement pod through a controller. The official example uses Debian, command print env, and 2 arguments. The command is the executable. The args are passed to that executable as separate array items. After applying the pod, it may complete quickly. Use kubectl logs to see what the process printed, just like any other container standard output. The YAML shape matters. Command and args are arrays. Kubernetes passes each item as a separate argument. It does not split a single string the way a shell would. A container command is not automatically run through a shell. If you need shell features like pipes, redirects, loops, or variable expansion by the shell, invoke the shell explicitly. For a shell command, set command to /bin/esh, then pass -c and the script as args. Now the shell interprets the loop and semicolons. Use a shell when you need shell behavior, but do it intentionally. Shell wrappers add quoting complexity and can affect how signals reach the actual application process. Many images are designed with a useful entry point. In that case, set only args to change flags or runtime mode while preserving the image's intended startup command. Set command when you intentionally replace the image entry point. This is common for one-off diagnostics, demo pods, or images that contain multiple tools. For quick diagnostics, command and args make the pod explicit, run a lookup, print environment, or sleep long enough to exec into the container. Kubernetes supports environment variable expansion inside command and args using the $parentheses form. That is different from shell $variable expansion. Environment variables may reference each other, but ordering matters. A variable that uses another variable from the same list must come later, and circular references are a design mistake. The official example builds message from greetin, honorific, and name, then passes message as an argument to echo. The container receives the final expanded value. Keep the 2 expansion systems separate. Kubernetes expands $parentheses references in the pod spec. A shell expands $variable references only if you run a shell. For simple values, use env. For a whole config map or secret, env from can import every key as an environment variable, optionally with a prefix. A practical pattern is config map to environment variable to argument. The pod remains generic, and the runtime behavior comes from Kubernetes configuration. Be careful with sensitive data. Arguments can appear in process inspection, debug output, or logs depending on the app. Prefer files or environment references when that reduces exposure. The official command demo uses restart policy on failure. That matters because print env exits. With on failure, a successful command does not keep restarting forever. For real applications, do not hand edit naked pods. Put command and args in a deployment pod template, then change them through a rollout so Kubernetes replaces pods safely. When a pod will not start, inspect the pod and events first. A missing executable, wrong path, or bad shell quoting usually appears in the container state or event messages. If the process starts and crashes quickly, use previous logs. That gives you standard output and standard error from the last terminated container instance. Use a checklist. Is command an array? Does the image contain that executable? Are you relying on shell syntax without a shell? Are flags separated the way the process expects? Argument splitting depends on the application. Some tools expect --port and 8080 as separate arguments. Others accept --port equals 8080. For CKA style work, remember the loop, create the pod or deployment, set command and args in YAML, apply it, inspect pod phase, check describe output, and read logs. The clean mental model is this. Command chooses the executable, args chooses the inputs, environment supplies runtime values, and a shell only appears when you explicitly run one.